Part one of this lesson talked in general terms about how concurrent and non-concurrent collectors perform differently when used in parallel and sequential streams on different input sizes. And now we're going to take a deeper dive into the EX36 case study, focusing initially on the implementation of the driver program in part two of the lesson. So we're now in the project for my EX36 example case study. And if we click on EX36, this will show the driver program, which creates different types of sets that, as is our tradition, contain words from the works of Shakespeare, in this case, unique words from the works of Shakespeare. And this will demonstrate the difference in overhead between collecting results using a parallel stream versus a sequential stream. Also, it'll show the use of concurrent versus non-concurrent collectors for different types of Java set implementations, such as HashSet, TreeSet, and so on. So let's go ahead and take a look at this. You can see here that we have a helper interface called a quad function, and this will take 4 parameters, and it'll have an apply method that applies all 4 parameters and returns a result that is the R parameter. So we have P1, P2, P3, P4. Those are different type parameters, and then we have an R parameter for the result. You'll see how that gets used to simplify some things in just a bit. We're going to run the timing tests 5 times to try to see if we can get some differences in performance that only show up if you do the test multiple times. We're going to read the complete works of Shakespeare from this file, which has the complete works of Shakespeare. We've looked at this many times before. And then we're going to do something really funky here. Check this out. We're going to have a regular expression that will be used to take the complete works of Shakespeare and break them up into, or break up the complete works of Shakespeare into words. And so, believe it or not, this crazy regular expression will break the works of Shakespeare up into words, omitting white space and punctuation. So we'll eliminate white space and punctuation and just have the words left. Took me a while to get this correct. Nowadays, I probably would have used ChatGPT to do that. But back in the day, I had to read the manual and play around with it until I got it to work. Okay, so first thing we're going to do is we'll warm everything up. I'll kind of skip over that. We want to make sure that when we do benchmarks with concurrency that we run the program methods and test data at least once to warm everything up so that the fork join pool is properly cached, and then we'll actually run the tests. So I will start running the tests in the background just because they take a while to run, and we'll keep talking about what the tests do. So you can see that we're going to run this run set collector test method twice. The first time we're going to run it on hash sets, and the second time we're going to run it on tree sets. What's the difference between a hash set and a tree set, you ask? Well, a hash set, as you probably can figure out from the name, uses hashing to distribute the keys into the hash table, whereas the tree set uses a balanced binary tree. And we'll see that there's pros and cons to each approach. Both tree sets and hash sets, by the way, take a while to merge compared to, say, an array list or a linked list where you just have to tack the result onto the end. So we're doing this deliberately in order to see the benefits of using concurrent collectors that don't accumulate into intermediate results that get merged, but instead do the accumulation directly into this one and only concurrent mutable result container. And then we're also going to see that both these things run, each of these run these tests both concurrently and sequentially. So let's see what else we're passing as a parameter in addition to the name that we're going to use to print out the results. We also give a method reference. It's actually a constructor reference that knows how to make a hash set for this test and a tree set for this test. And this is what's used for the non-concurrent collectors. Non-concurrent collectors are going to accumulate into essentially non-thread safe collections like hash set or tree set. We're also going to provide constructor references or method references, which are constructor references in essence, for a concurrent hash map. And in this case, we're going to make a concurrent hash map with a key set here. And down for the tree set, we're going to just pass in the tree set. And you'll see how those things get used under the hood. It's pretty cool. The reason we're doing this is that concurrent hash map uses a hash map internally to do its set manipulation. And so we're going to get an optimization from doing that. Whereas down here, we're going to embody this tree set into a concurrent collector that we develop. And you'll see how that works in a second. And then the final thing we do is we pass yet another parameter called time stream collect. So if you go take a look at time stream collect, this is really the workhorse method that it actually does the processing. And so what it's going to do is it's going to take a string that contains the type of the test, a flag that indicates whether things run in parallel or not. And then we're going to take a list of words, which constitute the list of the words of, in this case, Shakespeare, to manipulate and manipulate them. And then we're also going to take the collector that's used to combine the results. So that's the parameters that are passed to time stream collect. So let's take a quick look at this, and then we'll show the bigger picture view of how this all works. So the first thing that we do is we run the garbage collector before each of the tests, which will make sure we start with a pristine state of all the memory available. We'll then go ahead and set the name of the string to either be parallel or sequential, depending on what kind of test we're running. And now we're actually going to run the test. And this is kind of fun. You've seen the run timer time run method many times. It basically starts the timer by taking the current time of day, runs the runnable, which runs the test, stops the timer, records that time, and then stores that into the result map, which is just basically a hash map. So that's how we keep track of the time. This is what we do to actually run the test. So we go from I equals 0 to I less than S max iterations, which in this case is 5. We box those values up into integers so that we can call our good friend the map multi method. And map multi is going to call this method here called get results. And you can see that we'll see what the get results method does in a second. And what it's going to do is it's going to essentially take the list of words that are the list of words of Shakespeare to modify, and then it's going to go ahead and run either in parallel or sequentially, depending on which flag was passed in. And we're going to modify the words by rot13ing them, which is just to do some stuff to touch the data. And we're going to rot13 on uppercase versions of each word, and then we're going to lowercase it to the lowercase version. And then we're going to go ahead and collect the results using the collector that we passed in. So that's what get results does. So get results is going to return a set that is going to be returned back here. And that set will then be accepted into the consumer. And so what we're basically going to do is we're going to have a stream of the results, and we're then going to go ahead and convert the stream into a list. So we're going to end up with a list of strings that correspond to the unique words in Shakespeare. Just a quick note on map multi. This is important for you to be aware of for programming assignment 3B, which hopefully you're wrapping up because it's due shortly. And basically what you do is you take something that comes back as whatever, a set, a stream or whatnot, and you want to take each thing and essentially accept it into the results that come back. So what we're going to do here is we're going to take the set of words and we're going to accept them, and we're going to end up here basically with a stream of these results, which we're then going to convert into a list. So you can see we have a list of strings as the final result. So that's what's going to be timed. So we're going to time all of that. All right, so that's the way that time stream collect works. Now let's go take a look at run set collector tests. So run set collector test takes the name, the supplier for the non-concurrent collector, the supplier for the concurrent collector, and then the quad function, which is that thing that we just took a look at a second ago that was the one that did this, which is time stream collect. So let's go ahead and take a look at what we do now. So what we're going to do now is we're going to create tests with a different number of input data. So 1,000 words of Shakespeare, the first 1,000 words of Shakespeare, the first 10,000 words of Shakespeare, the first 100,000 words of Shakespeare, the first million words of Shakespeare, and so on. And we're then going to go ahead and use our get input method, which will open up the complete works of Shakespeare, load it into memory as a byte string, a string of bytes. So we're going to read all the bytes in that file of the complete works of Shakespeare here, turn it into a string, and then we're going to split that string by the regular expression. And if you remember, the regular expression that we had over here was this crazy regular expression. So that's going to end up essentially splitting things up into words only. So we split the byte array of all the words of Shakespeare into a stream of just words, filter out any any words that are empty, and then only collect up to a limit number of these words into strings. And then we collect the results into a list of these character sequence objects. And I think they're actually string objects. So let's change that. So we end up with a list, which is a list of all the words of Shakespeare. That's the long and the short of it of what we're doing there. So we get the list of all the words of Shakespeare as an array list. We print out some diagnosis, and then we start applying the collect method. Remember, the collect method is the one that we looked at that's going to run the collector portion, either in parallel or sequential, either for the version that is a non-concurrent collector or a concurrent collector. And you can see here, we're going to sometimes run it for sequential stream, so non-concurrent collector with a sequential stream. We're going to do a non-concurrent collector for a parallel stream, and we'll look at this in more detail in a second. Then we're going to run a sequential stream with a concurrent collector, which is kind of a silly thing to do, but we're doing it just for completeness. And then finally, we're going to run a parallel stream for a concurrent collector. And you can see what we do is we pass in the word array, the array of the words in Shakespeare, which can include duplicates. We just take the words out of there. And in this case, we're going to use a collector that's going to collect into a collection of whatever the set supplier is, either a tree map or a tree set or a hash set. And then down here, we're going to create the appropriate concurrent collector, which will also either be a concurrent collector that's a concurrent hash set or a concurrent collector for a tree set. So that's basically how these things work. Now we're going to come back and look at the concurrent set collector later, but I want to first kind of show you what the results are going to be before we do that.